They needed something to get back into the game, and Hubble was sort of that big shining star.
For over 34 years, the Hubble Space Telescope has been our eye on the universe, uncovering secrets no one ever imagined. But here's the twist. Hubble has been seeing things it was never designed to discover. From distant galaxies to hidden wonders in our own solar system, this telescope has repeatedly stunned scientists. What if I told you that some of the most incredible objects in space are right next door, hidden in plain sight? Join me as we blast off on a cosmic journey, exploring the mysteries of our solar system and beyond through Hubble's sharp eye. Our adventure begins with our closest neighbor, our moon. The moon. The huge apparent size of the moon in our sky is a significant challenge for the Hubble telescope. Unlike other space objects, the huge surface area of the lunar satellite cannot be framed in one shot. Thus, other space missions, especially the Lunar Reconnaissance Orbiter from NASA, have been more capable of capturing the huge surface area of the moon. Because of these reasons, the resources of Hubble are spent more valuably on other astronomical objects. But in 2012, it managed to take a very interesting picture during one of the rare alignments of Earth, Venus, and the Sun, when Venus passed across the face of our solar companion. This rare configuration allowed scientists, for the first time, to take advantage of the moon as a giant mirror. Using the moon as a reflector, researchers were able to detect subtle changes in light scattering patterns through the atmosphere of Venus. These minute changes showed previously unknown details about the planet's gaseous envelope, despite its composition already being well documented. This experiment was an important test case for the accuracy of the light scattering method for analyzing exoplanet atmospheres. Hubble has been using this technique frequently, studying the atmospheres of worlds beyond our solar system when they transit across their parent stars. Our sun is too luminous and would overpower the sensors on the telescope during such observations. The moon's reflective surface proved invaluable in allowing scientists to collect the data they needed. The Hubble spacecraft could hardly capture the whole of the lunar surface due to severe technical difficulties. In dramatic contrast, Mars is a much more approachable object for observation. Its red ground can be fully mapped through Hubble's imaging. Such mapping will provide insights into Martian weather, geological processes, and habitability. These full datasets are needed to prepare future robotic missions and establish a comprehensive understanding of Martian climatic conditions. Time-lapse sequences taken by Hubble provide a fascinating insight into the red planet's dynamic environment. One dramatic example shows a global dust storm swallowing the entire planet, hiding even the tiniest details of the surface. Against the bright orange clouds swirling around, Mars's small moons, Phobos and Deimos, can be seen hurtling quickly around their parent world. This is most evident in longer exposure sequences, where their rapid motion discloses the singular orbital properties that distinguish these small satellites from other objects. Of the two natural satellites of Mars, the larger and closer to the planet is Phobos, which exhibits a very peculiar orbit. This little moon orbits the planet in only 7.5 hours, making it the only satellite in our solar system that orbits its host body faster than the host body's rotational period. To put this in perspective, a time-lapse centered on Phobos demonstrates its motion over just 22 minutes, revealing the moon's incredibly fast speed as it whips through space close to its parent planet. As we go farther in our journey through space, crossing over the inner planets, comes the first of the gas giants, Jupiter. But before arriving at that massive world, there is another prominent feature of our solar system, the asteroid belt. Within this vast area between Mars and Jupiter, countless small rocky bodies fill the space, the leftover material from the dawn of the formation of the planets. These ancient relics provide a vital insight into the history and evolution of our celestial neighborhood. Now that we've taken a closer look at our moon, let's venture further into the solar system, where mysteries continue to unfold. Beyond Mars lies a region full of ancient relics that hold the keys to understanding the early days of our solar system. But don't be fooled. What we find in the asteroid belt may be just as surprising as any of the distant worlds we've encountered. Get ready, because Hubble's next target is an asteroid unlike any other. The asteroid belt. The asteroid belt is an interesting region filled with objects of various kinds. Many opportunities present themselves for scientific studies, one of which is the curious asteroid 6478 Gault, a mislabeled heavenly body that has now captured Hubble's attention. You may be surprised to discover that this object, with twin tails like a comet, is actually an asteroid and has been named Gault. This extraterrestrial creature inhabits the asteroid belt and was imaged in the year 2019. So why does it have a tail? According to scientists, the answer lies in a phenomenon called the Europa effect. Solar radiation exerts a small but steady force on irregularly shaped bodies, and under the right conditions, this can gradually increase their rotation speed. In Galt's case, its 3.5 kilometers wide body has been spinning faster over time, and now completes one rotation every 2 hours, the upper limit of what an asteroid can endure. This rapid rotation generates centrifugal forces stronger than the asteroid's gravity, which causes loose material to be ejected into space. Those ejected particles form the tails, and Galt will most likely disintegrate entirely over time. Like many other asteroids and comets, Galt is not a monolithic rock, but a fragile rubble pile that is held together by weak gravitational forces. Such a structure is especially susceptible to the effects of solar radiation and collisions. The asteroid belt, a region of chaotic population with 1 to 2 million asteroids larger than a kilometer and uncountable smaller ones, is a dynamic region. To illustrate this complexity, let's look at P2010A2. It appears at first to be a fairly typical comet, but it has been discovered that its nucleus is unlike any other seen before. The filamentary structure is clearly not normal. Incredibly, this is not a nucleus of a comet. It's not even a comet. What we are seeing here is a truly rare occurrence, an asteroid collision. The X-shaped structure near the nucleus comprises debris from the impact, with rubble being ejected in 4 directions. Some of this material is pulled back toward the center of mass by the faint gravitational pull, while particles in the tail have escaped completely. This collision really shows how chaotic the asteroid belt is. In spite of all that chaos, most of the asteroids in this region move in relatively stable circular orbits around the Sun. If it wanders too far from such a path as comets do, it's likely to encounter a much stronger gravitational force. This thin line between stability and instability makes the asteroid belt so interesting for astronomical study. Moreover, the variety of objects present in the asteroid belt provides scientists with a huge number of research opportunities. From small, rocky bodies to large, possibly habitable worlds, each object holds clues to the formation and evolution of our solar system. The study of these space bodies will increase not only our knowledge about space, but also contribute to understanding the process of planetary formation and the beginning of life on Earth. In the end, the asteroid belt, with its rich population of objects, has continued to inspire astronomers and astrophysicists alike. The discovery of asteroids like Galt and events such as the collision observed in P2010A2 remind us of the vast mysteries still waiting to be uncovered in our solar system. With advanced technology and new missions launched, we may find even more secrets hidden within this fascinating region of space. Jupiter. Jupiter, as many people say, Jupiter is the solar system's vacuum cleaner. Its enormous mass dominates the immediate space around it. This enormous mass comprises almost 3/4 of all the matter in the solar system, excluding the Sun, and its gravitational pull shapes the destinies of nearby celestial bodies. One dramatic example of this was the near approach in 1994 of the 2-kilometer diameter comet Shoemaker-Levy 9, which came so close to Jupiter that the planet's gravity broke it apart into a string of pieces by the time the fragments hit Jupiter. This was the first time in history that scientists had observed a collision with another body in space. Interestingly, Shoemaker-Levy 9 had been captured by Jupiter about 20 years previously and was orbiting as an active comet, a first ever observed occurrence. Over time, the orbit of this comet brought it so close to the surface of Jupiter that it got shredded by tidal forces. A year later, its fragments hit Jupiter with a whopping speed of 60 kilometers per second, or over 210,000 kilometers per hour. The impacts onto Jupiter produced fireballs at temperatures in excess of 23,000 Kelvin that shot upwards 3,000 kilometers over the limb. The giant hit left a dark patch around 12,000 kilometers wide, just about the size of Earth, and released energy equivalent to 6 million megatons of TNT, exceeding more than 600 times the power of all nuclear armaments combined in the world. While less spectacular than others, some impacts have been recorded and snapped, with photos giving more credence to the belief that Jupiter has been a cosmic vacuum cleaner for the inner planets from destroying collisions. Beyond its enormous gravitational pull, Jupiter provides some rather ethereal phenomena that are of interest to astronomers. Earth is not unique in having auroras, for example, but these are visible on Earth only to the naked eye. Curiously, auroras are brightest in ultraviolet light, thanks to the capability of the Hubble Space Telescope to reach ultraviolet wavelengths. This has enabled us to study these brilliant displays in some detail on other planets. Jupiter's auroras will be the easiest to observe, given the unique nature of this planet. Not only is Jupiter the largest and nearest of the gas giants from Earth, but it also features a very strong magnetic field with intense radiation that creates spectacularly bright auroras. The scientists took advantage of the proximity of the Juno spacecraft on its flyby to Jupiter in 2016 to make parallel measurements of solar wind and its impact on Jupiter's aurora with Hubble. This collaboration enabled Hubble to study Jupiter almost daily for several months. The results showed that Jupiter's auroras are vastly more powerful than Earth's, emitting a total of 100 terawatts of radiant energy. Surprisingly, whereas Earth's auroras are highly variable and linked to solar activity, Jupiter's auroras are quite steady. This indicates that the solar wind is not the sole driver of Jupiter's auroras. Data from Juno shows that Jupiter's intense radiation belts feed charged particles into the atmosphere through magnetic field lines. Furthermore, the aurora's brilliant energy is accounted for by alternating rather than direct currents in the magnetic field. This would not be possible with direct current energy transfer. Having discussed Jupiter in general, let us talk about one of its more interesting moons. It is an active volcanic moon, and it provides a chance to learn about geological processes under extreme conditions. Its surface is dominated by hundreds of volcanoes and lava flows, which create an alien landscape that informs us about the internal heat budget and tectonic activity of the moon. While Jupiter's vast and turbulent atmosphere presents us with spectacular sights, one of its most intriguing moons is hiding a mystery far beneath its icy surface. Imagine a world with a vast, hidden ocean that might just harbor life. Let's dive deeper into Europa, where the secrets of this frozen moon could hold the key to finding extraterrestrial life right in our solar system. Europa. The mysterious frozen planet could theoretically harbor the closest known extraterrestrial life to Earth. The Hubble Space Telescope has produced a sharp view of Europa. Since it is so distant from Earth, this major moon of Jupiter is among the best candidates for supporting life within our solar system. However, it is not on its surface, but buried beneath its ice crust in a deep ocean comprising liquid water. Europa's close proximity to the gas giant Jupiter creates an incredible gravitational pull that results in a phenomenon called tidal flexure. This process creates internal heat, which scientists theorize keeps the ocean beneath Europa's icy surface at a temperature that would keep it liquid. Many missions have attempted to confirm the presence of this subterranean ocean, and Hubble has played an unexpected part in those efforts. While high-resolution images from Galileo and Voyager are captured at close flybys, they did not have the capability to perceive ultraviolet radiation, an obstacle that Hubble had overcome. The observatory has detected what appears to be water vapor plumes bursting out of Europa's surface. If confirmed, such volcanism would provide strong evidence for a liquid interior mantle and bolster the ocean hypothesis. Many other plumes have been found on Europa since the first observation. The Space Telescope Hubble's power was also employed to locate mineral deposits on the surface of the moon. Most planetary missions use infrared photography to observe planetary surfaces because infrared hosts most of the fundamental emission spectra of materials. Sodium chloride, or table salt, is primarily visible within the visible light spectrum, which explains why Galileo, who relied on this spectrum, was unable to detect these mineral deposits. The fact that Hubble could view invisible light made it possible to detect the presence of sodium chloride scattered all over Europa's surface. This leads to a belief that these mineral deposits have emanated from the subterranean ocean to the surface through the plumes and have been deposited there. The possibility of sea salt on Europa is quite tantalizing and would, if true, indicate that hydrothermal activity occurs on the ocean floor just like on the Earth. Hydrothermal springs underwater, also called vents, are hotbeds of organisms, making it a potentially rewarding avenue of search and research. However, the prospect of a submarine mission to probe Europa's ocean remains distant, at best, several decades away. As we continue our journey through the outer planets, we find ourselves at the threshold of yet another fascinating world, ripe for scientific inquiry and discovery. Saturn. By 2017, Saturn had remained unexplored by dedicated spacecraft, with the Hubble Space Telescope serving as our primary instrument for studying this gas giant. Hubble frequently observes Saturn, monitoring phenomena such as atmospheric conditions and seasonal fluctuations. Cassini's exploration lasted only half a Saturnian year, so Hubble now plays a crucial role in filling data gaps. Among the most dramatic and striking events Hubble has viewed are gigantic storms measuring thousands of kilometers across Saturn's disk. But the telescope does more than produce scientific breakthroughs on the Saturnian system. It can reveal beauty. Here are a few of the best images taken so far. In our final stops on this virtual tour, let us first visit the first of the icy giants. Beyond Saturn, we encounter a planet that challenges everything we know about the solar system, Uranus, with its tilted axis and strange magnetic field. Let's dive into what makes this icy giant so fascinating. Uranus. While Jupiter and Neptune present interesting phenomena in their atmospheres, Uranus has to offer a variety of interesting features that distinguish it from other planets. Among them, the most mysterious one is its magnetic field, where the spectacle of auroras near its polar regions competes with Jupiter's more famous storm systems. Curiously, the magnetic poles of Uranus are not aligned with its rotational axis, which is a very curious state of affairs that makes it even more mysterious. What makes this weirdness even weirder is that Uranus's rotational axis is tilted extremely, leading it to almost roll perpetually in its orbit. This strange tilt also drastically affects the patterns of solar eclipses for Uranus and makes them rare events. The first recorded passage of a moon's shadow across Uranus occurred in 2006 and was quite an event in astronomical observation. Previously, the last alignment occurred in 1965, when telescopes with the capability to observe such far-away celestial events were not developed. The historic observation provided stunning pictures of aerial shadows transiting across the surface of Uranus, courtesy of NASA's Hubble Space Telescope, offering new insights into the composition of the planet's atmosphere. Continued observations from Hubble have since that groundbreaking moment revealed seasonal changes in Uranus's atmosphere over various stages of its 84-year orbit. When one pole of Uranus tilts towards the Sun, its atmosphere changes and forms a large cloud cap during that summer, a rare phenomenon in our solar system. It is important to note that with Hubble, only less than half of a complete Uranian year has been observed, because it's a relatively young age of 34 years. Consequently, much remains to be discovered about the seasonal dynamics and atmospheric behavior of this planet. As scientists continue to study this enigmatic world, they may still come up with more secrets lying beneath its peculiar tilt and atmospheric quirks. Last but not least, Hubble made the most important discovery, the smallest known moon of Neptune, baptized as Hippocamp. This small object is a pretty interesting topic for further investigation. It will bring important knowledge about the beginning and development processes of small moons in the solar system. Hippocamp. The lack of sophisticated telescopic facilities has highly hindered our ability to track the celestial bodies. Our knowledge of far-flung planetary systems would be elementary without the observing power of the Hubble Space Telescope. The two outer gas giants, Neptune and Uranus, have long been largely neglected by space agencies. There has been only one close flyby, Voyager, in 1989 that provided serious knowledge about these mysterious planets. We, therefore, have a patchy knowledge of the extraterrestrial world. The discoveries made by the Hubble Space Telescope have been quite groundbreaking in expanding our knowledge of the cosmos. One of the most fascinating, in 2013, was that it revealed a previously unknown satellite of Neptune, subsequently named Hippocamp. While Hubble has made a fair number of discoveries in regard to moons, especially those orbiting Jupiter and Saturn, Hippocamp stands out because of its proposed link with Neptune's largest moon, Proteus. The peculiarities of the Hippocamp and the mode of its formation have opened up interesting avenues for further astronomical studies and speculations. Its discovery has underlined that so much mystery is still hidden in our solar system, which will continue to be unfolded by space missions and future technological advances. Further continued observations using the Hubble Space Telescope and similar other facilities are vital to unraveling the secrets of our neighborhood in space and expanding the knowledge base of humankind about the universe. Proteus. Proteus is a huge Neptunian moon, approximately 400 kilometers in width, and with clear evidence of a violent history. Its surface is scarred by catastrophic collisions that resulted in impact craters 50 to 100 kilometers in diameter. A single huge collision might have shattered Proteus into pieces, sending these fragments of debris into orbit around Neptune. The largest of these shattered remnants, and an irregularly shaped celestial body about 35 kilometers long, Hippocamp is thought to have a close orbital path to its parent moon. As we get close to the end of our interplanetary journey, let us reach an even more in-depth view of the fantastic realm itself, Neptune. Its specially composed atmosphere, powerful storm systems, and the mysterious blue color of the planet that has occupied astronomers for centuries. That also explains why Neptune, more so than any other part of our solar system, is one of the best sources to find many of the secrets about the formation of a planet. Neptune continues to yield secrets about our cosmic neighborhood and has inspired new generations of space enthusiasts. Such natural human curiosity about that great universe we live in needs to be fed through every nook and corner. Neptune. The versatility of Hubble within the field of astronomical exploration has been invaluable in our quest to understand objects beyond Earth's orbit. This space telescope was not originally designed for the express purpose of monitoring the solar system. However, the adaptability of this spacecraft has allowed significant discoveries about our cosmic neighborhood. The ice giants Neptune and Uranus have been among the prime focal points of the research studies conducted by Hubble. This continuing research has permitted scientists to observe seasonal changes in these planets' atmospheres with unprecedented accuracy. The data gathered has added extensively to our knowledge about atmospheric dynamics in those far-flung worlds. The most striking feature that Neptune presents to an observer, in a literal sense, is its truly colossal tempests thousands of kilometers across. These giant storms have impressed astronomers enough with their tremendous sizes and fleeting nature. A massive storm could be observed from Voyager 2's historic flyby in 1989, later to be baptized as the Great Dark Spot. The striking similarity to Jupiter's own famous Great Red Spot was, however, quite different in behavior. Whereas Jupiter's Great Red Spot has persisted as a stable anticyclonic storm system, Neptune's Great Dark Spot proved to be considerably more transient. It had disappeared just a few years after its discovery, only to be followed by newer storms that similarly appeared and disappeared over the years. The most recent of these colossal whirlwinds was observed in 2018. Although its duration was substantial, lasting several years, it too has seemingly disappeared. This cyclical nature of Neptune's storms has puzzled scientists, leading them to hypothesize about the underlying mechanisms driving these atmospheric phenomena. One hypothesis is that Neptune, much like Jupiter, has bands of atmosphere that move at different velocities. Where these bands meet, they may form vortices or storms, much like on Jupiter. This is also evidenced by the circulation patterns in Jupiter's atmosphere. Once a storm has developed on Neptune, it drifts across the surface of the planet, sometimes crossing from one of these atmospheric bands to another. As it loses its source of energy, however, the storm gradually dissipates, which accounts for the relatively transient nature of Neptune's vortices in comparison to Jupiter's Great Red Spot, which has persisted for centuries. This makes Hubble the only observatory that can track these atmospheric changes. Its capability to study the planets in the ultraviolet spectrum provides scientists with a lot of vital information about their weather. This has given researchers an advantage in studying those things that would remain a mystery had the light coming from these faraway planets been too dim. The study of the atmospheres of Neptune and Uranus has also contributed to knowledge in the general field of planetary science. By putting these ice giants into context with better-known gas giants like Jupiter and Saturn, researchers are able to further understand atmospheric dynamics across different types of bodies. The conclusion of our journey through the solar system brings us to the realization that we still have much to learn about our cosmic neighborhood. The study of Neptune and Uranus serves as a poignant reminder of the vast mysteries in our celestial backyard. Before we say goodbye to the tour of the planets of the solar system, there's one more interesting world that comes to mind, a dwarf planet that has captured the imaginations of astronomers worldwide. You might think of Pluto straight away, but we're not talking about that. Meet 2007 or 10, also fondly known as Gong. It is an enigmatic world that was discovered in 2007 and orbits beyond Neptune in a part of space known as the Kuiper Belt. Its very unusual characteristics make it an intriguing subject for study, offering scientists insights into the formation and evolution of our solar system. The observations of Gong by Hubble have given a lot of valuable information about the size, shape, and surface composition of this faraway world. It has greatly expanded our knowledge of these small, icy bodies that populate the outer reaches of our solar system. As we reflect on the journey undertaken through the planets, we realize that each and every one of them has something to show, be it their sizes or distances from Earth. The study of the world is continuous. improving our knowledge about astronomy and, generally, the universe. It also encourages fresh scientists and space explorers. Beyond the reach of Neptune, in the icy darkness of the Kuiper Belt, lies a world so mysterious it's been hiding in plain sight. What secrets does Gong hold, and what surprising discovery has Hubble just unveiled? 2007 or 10. The astonishment that this is not a widely recognized celestial entity is justifiable, to say the least. Being the third largest dwarf planet in the solar system, it is below only Pluto and Eris in terms of widespread fame. Similar to other more renowned dwarfs, Gong sits 1 billion kilometers away in the Kuiper Belt. Although Hubble didn't spot Gong, it played a crucial role in the discovery of one key characteristic of this mysterious world. Gong has a moon. That hadn't been discovered earlier because the moon appeared too faint in previous images. However, a study published recently hinted at the moon's presence based on Gong's very slow rotational period of almost 45 hours. Most Kuiper Belt objects spin in less than 24 hours, and astronomers theorized that the drag from a moon's gravitational tug might account for such sluggish spin. To confirm the moon's existence, the team reanalyzed archival Hubble observations. The discovery adds to an intriguing pattern. Almost all known Kuiper Belt dwarf planets have moons. This could be a result of the slow collisions in the Kuiper Belt. The Kuiper Belt objects move slowly enough that the fragments from impacts would be gravitationally bound to form moons, while in the asteroid belt, such collisions are far more energetic, flinging debris into space rather than merging them into moons. Identification of the moon of Gong is an important contribution of valuable data for refining our models of the formation of the solar system. This seemingly insignificant discovery adds another crucial piece to the puzzle of understanding our cosmic neighborhood. Considering such amazing discoveries, it becomes clear just how instrumental Hubble has been in expanding humanity's comprehension of space and our solar system over the last 3 decades. It has outperformed expectations by miles, offering insights and images that will fuel scientific discovery for many years to come. What's more, Hubble isn't anywhere near the end of its mission. If properly cared for, it might still go strong until 2040 and outlive its spiritual successor, the James Webb Space Telescope. Such longevity really brings into perspective the fact that humanity's knowledge about space isn't going anywhere. These findings are important, considering their implications outside our solar system. They give a greater understanding of the nature of the celestial bodies found elsewhere in space. It is not just knowledge. Rather, it is also serving several practical purposes in space exploration, astronomy, and even colonization initiatives likely to be undertaken in the near future. These discoveries, however, show that investment in space research is still relevant. The technological and scientific developments brought about by missions like Hubble create the foundation for the next generation of space explorers and scientists. They inspire new areas of research and push the boundaries of human understanding. If you found this piece of information enlightening, feel free to share it with fellow space enthusiasts. It is great that you have a curiosity about the cosmos, and taking care of such a curiosity will only foster more discoveries and appreciation for life in the universe. As we continue to explore and learn about our celestial neighborhood, remember that there's still much to uncover. The mysteries of the Kuiper Belt and beyond await us, and ongoing research is crucial to unraveling them. Until next time, stay curious and keep looking up. You never know what marvels you might observe in the vast expanse of our cosmos.